Right, so let's look at starting to solve logarithmic equations. Now, remember, a logarithmic equation has to have a log in it, and it has to have an equal sign. That's what makes something an equation. But here's something that's really, really important to understand. A logarithm is not defined for any negative number or any zero. So in other words, any log, if you're going to put a value here, right here, that x has to be greater than 0. Because if you actually boot up your calculator and you do a log of a 0, or if you do a log of some kind of negative, and we'll just put down -2, both of those will go kaboom in your calculator, and your calculator just won't work properly, okay? So make sure you realize that this doesn't happen. So what does this mean? This means that we now have restrictions. Yes. Restrictions, very much like if you look back in earlier grades and earlier courses, we call these NPVs, non-permissible values. In other words, values that are not allowed. So what we have to look at is, let's look at our first equation here, and it'll be really, really easy to figure out. Look at this. You have a 9x right here. Now, I'm not even going to solve this equation until I figure out the non-permissible values. So it's important to write down 9x has to be greater than 0. It's not greater than or equal to, because remember, one of the restrictions is it can't be a 0 either. So just solve it. Divide by 9 tells you all the x values have to be greater than 0. That makes sense. Look at this one. X has to be greater than 0. That just solves it. Now, both of these are the same, so that's what makes this particular question really, really easy. But I'm going to show you something else in another question right away that makes it a little bit more challenging. One step at a time. Here we go. How do we solve this thing? Well, we have to come back and we have to look at the log laws. And if you remember the log laws, let me just erase this here and get this out of our hair. If you remember the log laws tell you that when you see a plus like this, all you have to do is multiply it. So here we go. Log base 3, 9x times x. That is going to equal to 4. Now, if you do this, this is now log 3 9x squared equals to 4. Now, some things, some different books have different ways of doing these things. And a lot of you talk to different teachers and they'll have different ways of doing this. But one of the things that I like to do is I like to take this here and make it into a log base 3. And I'm going to show you why in a couple seconds here. So let's go back to our basics. What value do we put here to make this log base 3 equal to 4? And if you remember correctly, all we do is take 3 to the power of 4. There it is, 3 to the power of 4, which is 81. You could work it out in your calculator if you want. That's this 81 that goes here. So 4 can actually be represented, this 4 here can be represented as log 3 of 81. Now check this out. Now you've got log 3 here of 9x squared. As soon as you get a log, a complete log equals to another complete log, these logs can actually cancel, gone, leaving you with a really pretty equation. 9x squared equals to 81. Oh my goodness, that is so easy to solve now. Okay, so how do we go about solving it? Simple. Divide by 9, just like we did before. So x squared equals to 9. Don't forget square root, x equals to plus or minus 3. Now, remember the non-permissible value that we had way back here. And if you want, you can back up the podcast and look for it. I'm just going to tell you that x had to be greater than 0. That was a non-permissible value, or in this particular case, what we call a restriction. Okay, so a restriction on our x has to be that it's got to be greater than 0. Well, take a look at our answer all the way down here. Our answer down here said plus or minus 3. So I got a question for you. X can equal to plus 3 or x can equal to minus 3. Well, remember the restriction that we had, we can't have anything less than 0. So that guy is toast. This is your actual answer. Okay, so that one is an extra answer, which we call, of course, extraneous. An extraneous answer, the answer that doesn't work. Now, how do you prove that this plus 3 actually works so to be your answer? Well, let's go back to our original. Go back to our original equation. We know the answer is x plus 3. Let's get rid of all this other stuff here. Okay, here we go, giving us a little bit more space to work with. And let's actually plug it back in to our equation here and see if we actually get it equal to 4. All right, log base 3 of 9, and x is 3, beautiful, plus log base 3 of 3, I hope somewhere equals to 4. Let's figure this out. Well, what's 9 times 3? Well, log 3 equals to, 9 times 3 is 27, plus log base 3 of 3. Okay, remember, power laws tells you that when it's plus, all you have to do is multiply this. So, okay, log base 3 of 27 times 3, right, which is log base 3 of 81. Now, how do you know this? What's the answer for this? Well, it's actually pretty simple. Go back to your basics, what we did over here, right? Log 3 of 81 equals to x. What value of 3 to the power of x equals to 81? And of course, if you think about it, this, of course, is going to be 3 to the power of 4. There's your 81 right there. It gives you a real nice number. Okay, so your x actually works out to be 4. And 4 on this side matches 4 on this side, proving this wonderful little equation. We'll do more in the next podcast.